Welcome. So we're going to answer this final part, which says find the maximum distance between t of x and k of x over this domain. State your answer correct to one decimal place. So now what we want to do, if we just scroll back to the very beginning, is we want to find the maximum distance between the graphs, the maximum distance. Well, this is going to be very much related to what we did in the previous part. We had found in the previous part a function that tells me the distance between the two graphs. Amazing. So when it's asking us to find the maximum distance, we just want to find the maximum value of d of x. That's what we want to do. We want to find the maximum value of d of x. How do we do that? How do we find the maximum value of d of x? Well, let's come to our graph, to our CAS rather. And here is the value of d of x, which we found by simply subtracting the two graphs from each other. And let's just define this. So d of x, control that is this, just like that. All right, now we come over here. I'm going to graph it. So I'm going to go tab, d of x. There it is. Now, we're just going to spend a bit of time really analyzing what this black graph is telling me. All right, let's begin on this side here. Okay, what I want you to notice, we've got this point of intersection between the red graph and the blue graph. So at this point of intersection, can you tell me what is the distance between the two graphs? Well, obviously the distance is 0 because they're touching each other. There is no distance between them. Well, I want you to take note. If I go menu, analyze, and this is actually probably easy if I go intersection, this and this. Do you see right there? Okay, so I'm holding the cursor over this. Do you see right here? When they're touching each other, what is the value of the black graph? The value of the black graph, which is d of x, is 0. So in other words, when x is whatever this is, d of x is 0. And that makes sense because it's 0 there. And we could do the same thing if we come, now this is where I'm going to have to come over here, menu, analyze, intersection, this graph and this graph. When we come over here, once again, the black graph is touching the x-axis when the two graphs are intersecting, which represents the distance being equal to 0 at this value here. So as you can see, the black graph, whoopsie daisy, the black graph is telling me the distance between the two lines. So if I want to find what the distance between the maximum distance is going to be, well, it's just going to be the maximum value of the black line. So I'll come here, I'll go analyze, I'll go maximum. Now, when you've got several different lines or graphs on the CAS, it's going to say, well, which graph do you want me to find the maximum of? You just select which one you want, then you go over it. And as you can see, when x is equal to 1.5, I'm going to get a maximum distance of 8.25. So this here, 8.25, represents the distance between the graphs at this point. So from here to here, that's your maximum difference, 8.25. So that means I can come over here and I can say, whoops, x is 8.25, which means if it's to one decimal point, 8.3. And that's how you answer that question. Hopefully that makes sense how to go about it. These are really great questions just to be able to critically think through what's going on here. All right, I'll see you later.